Hey guys, so today we're doing a video about the power rule for derivatives, and this is often the first derivative shortcut you learn, and it's pretty much the most helpful. You use it all the time. So what it says is if we have f of x equals x to the n, so just x raised to some exponent, an example would be x squared, then f prime of x will equal n times x to the n minus 1. So what this means is we take the exponent, we bring it to the front, we leave the x alone, and then we just reduce the exponent by 1. So as an example, let's just go through this first one I have. F of x equals, we'll just go through the very first term, 20x squared. What we're going to do is we're going to bring that into the front. That 2 is going to go to the front, so we're going to have f prime of x equals 2 times 20. And then x stays the same, x to the n minus 1, which is 2 minus 1. So we get f prime of x equals 2 times 20 is 40. X to the n minus 1, 2 minus 1 is 1, so that'd be it, 40x. So now let's do this entire derivative. We can get f prime of x equals, we already solved that was 40x. Then for our first term, if we have 3 just to the x, we can assume there's a 1. So we would bring that to the front, we'd get plus 3 times 1 is just 3. Then it'd be x to the 0, which is just 1, so it just becomes the constant of 3. And notice that anytime we have something just like x alone without an exponent, the derivative of that is just going to be the coefficient out front. So that's the entire derivative, because the derivative of 5, derivative of any constant is 0, so we don't have to put it. And now when we get into a little more complex examples, we have square roots, higher exponents, and then a fraction exponent. So what we need to do is for square roots, we need to write them as fractions. So if we remember f of x, I'm just rewriting it, the radical is like putting a fraction of x to the 1/2. That's the equivalent to the square root of x. So we need to rewrite it like that. Then we can leave this one the same, 3x to the 10th minus 3x to the 3/2. And now step 2 is just use the power rule like normal. So we bring the 1/2 to the front, so f prime of x equals, well, it's going to be 1/2 x, and then it's going to be 1/2 minus 1, which is just negative 1/2, plus 30x to the 10 minus 1, which is going to be 9, minus, well, we're going to bring the 3/2 to the front, so we'll get minus 3/2 x to the 3/2 minus 1, we'll be left with 1/2. And we could rewrite this. I'll rewrite it over here. This is the equivalent of, well, 1/2 x to the negative 1/2. Remember, negative exponents are the same as just writing them in the denominator. So we could say 1 over 2. And we already learned that x to the 1/2 is just a radical. So we can just say 1 over 2 square root of x plus 30x to the 9th. Don't need to change that one. Minus 3/2. And we could just say square root of x instead of x to the 1/2. Either way works. But this is the equivalent of this, and both are the derivative. Okay, so now we have one final example, kind of bringing everything we learned together just now. So let's say first step is always to rewrite, get rid of these radicals if we can. Okay, so we have 1 over x to the 1/2. Remember, if we have a square root in the denominator, we can just bring it to the top and just change the sign to a negative. So we can bring it as x to the negative 1/2. That's how we would write that. And then plus, again, we have an exponent in the denominator. To bring it to the numerator, we can just make it a negative. So this is the same as x to the negative 3 minus, okay, well now we have x squared, the cube root of x squared, and that is the same as x squared divided by 3. So x2 divided by 3 is how you can think of that. So now we can just solve the derivative like normal. F prime of x equals negative 1/2 x to the negative 3/2 now, plus, well, will be, well, actually a minus, because we have to bring that negative 3 out front. So it will be minus 3x to the negative 4th. It'll be minus 2/3 x to the negative 1/3. And that could be the derivative. We could write it like that, but we could clean up a little bit as well. So we could get f prime of x equals, we'll get negative 1/2, 1 divided by 2, and then again, we usually don't want to keep those exponents as negative, so we can make it the cube root of x squared. No, it'd be 3/2. It'd be the square root of x cubed, actually, my bad. Minus 3 divided by x to the fourth. Now we got to bring that negative exponent to the bottom to make it positive. Then minus 2 divided by 3. Now it's going to be x to the 1/3, so it's going to be the cube root of x. I hope that would help. Let me know if you have any questions.